So I want to review with you these problems that we had from last week. Number 2, we'll draw a new schematic, and I'm going to use a darker marker here so it's easier to see. We came over, we have 2 resistors. We have R1 and R2 in a series circuit. We know that E of R1 equals 25 volts. We know that E of R2 equals 175 volts. And we know that I equals 0.5 amps. This is the most important thing to know, because that's going to work for totals and also individual areas here. So what they're looking for are ET or VT, they're the same thing. They're looking for R1, R2, and RT. Okay? So those are the items we're looking for here. Well, we know what the voltage drop is here. We know what the voltage drop in here. There's only 2 loads, so we know both voltage drops. So VT is going to be very easy to find, right? VT is going to be 175 plus 25, or 200 volts, right? So R1, if we know what the voltage drop at R1 is, and we also know what the current is at R1, we can use those to find it here. So if I'm looking for R, I take my voltage drop at R1 and I divide it by the current at R1. So I would take, for R1 here, I would take 25 volts divided by 0.5. When we divide something by a half, you are recognizing after doing this yourselves that we're just basically multiplying it by 2, because we're inverting and multiplying of the 1/2. So 50 ohms. Okay, so 175 divided by 0.5 would be twice that, right? So we have 175 divided by 0.5 equals 350, which is twice 175, because we divided by half, multiplied by 2. So that's ohms. To find RT, 2 different ways to do it. Easiest way, I just add 350, and 50 is 400 ohms. Another way of doing it, though, I had IT and I had VT. So if I were to take, if I'm looking for RT, I would take VT and divide it by IT. So VT is 200 divided by 0.5 equals 400, which is another way of finding out that resistance there. Okay? So number 3. So numbers 3 and 4, they add a 3rd resistor in here. R1, R2, R3. We know R1 equals 100 ohms. We know R2 equals 200 ohms. We don't know what R3 is. We know that I equals 2 amps. And I put the I in the middle there again because that is our constant. That's going to be, at I of R1 we have 2 amps. At I of R2 we have 2 amps. At I of R3 we have 2 amps. And IT is also 2 amps. So we learned that I is constant in a series circuit here. Okay? So let's figure out what they want us to, do we have anything else that they've given us? Yes. They've given us E of R3 equals 200 volts, right? They want to know ET or VT, same thing. They want to know E3 here, and I told you before in the video that E3 is going to be the same, is going to be the voltage drop at 3. So they're the same thing. So I'm not even going to write that down. RT equals, and E of R1 Okay? So what's the first thing that we can do? We know R and I for 1 and 2, right? So we can find the voltage drop very easily there. If I'm looking for voltage drop, I'm going to take my current times my resistance. So 2 times 100. So the voltage drop at R1 is going to be 200 volts. Right? RT, well, we still have to find some things out here. We have a voltage drop here, and we also have our I. So we have E and I. So we take E, which is 200, divided by I, which is 2. So it'd be 100 ohms. So R3 equals 100 ohms. So to find RT, I'm just going to add them up. 100, 300, 400. 400 ohms. Okay? So now I have RT and I have IT, so I can find VT pretty easily, right? If I'm looking for VT, I take IT times RT. So 2 times 400 equals 800. 800 volts. So VT equals 800 volts. And that answers number 3. Number 4. Again, we have a series circuit that has 3 resistors in it. And these are resistors, but they could be loads, just any kind of load also. Really, they could be bulbs offering resistance, but the amount of resistance they're going to be offering is going to be larger than what a bulb would be doing. R3, they've given us E of R1 equals 50 volts. E of R2 equals 150 volts. E of R3 equals 200 volts. So they gave us all the voltage drops. So I'm just going to add those up to give my VT or ET. So it's going to be 200 plus 150 plus 50. So we're looking at 400 volts total. Okay? They also give us I equals 0.25 amps. And that's going to work for everything then. So they want to know what the resistance value of R1 is. Well, I know what E of R1 is, right? 50 volts. And I know what I of R1 is, right? A quarter. So this time, when we're taking 50 divided by 20.25, that's a quarter, so it's like multiplying it times 4, right? So we have 50 divided by 0.25 equals 200. So R1 equals 200 ohms, right? I took voltage divided by resistance. They also want to know what R2 is. R2 is, we know what the voltage drop there is, right? And we also know what the current there is. So 150 divided by 0.25, or 150 times 4, 600. And they want to know R3 also. So R3 is 200 divided by 0.25. 800 ohms. Okay? So if we wanted to find RT here, we could either take VT and divide it by a quarter, or B times 4, or we just add those up. They haven't asked us for RT though.